Hello, algebra learners, and welcome to another video lesson. We are in section 9-2, day 2. The previous lesson, we talked about how to find the axis of symmetry and how to find the vertex. And today, we're going to take that one step further and show you how to use those values to actually graph your function. So what I'd like for you to be able to do by the end of this lesson is to graph a quadratic function by first calculating the axis of symmetry, then the vertex, and then by substituting in appropriate values for x. So let's talk about the steps to this. There's 4 main steps of how to graph a quadratic function that's already in this form for you. Your first step is to find the axis of symmetry. So that's pretty important. We've got step 1, and we are going to find the axis of symmetry. And we're going to use that formula that you guys were introduced to in the previous day's notes, which is x equals negative b over 2a. For step 2, you're going to find the vertex. Step 2, you're going to calculate the vertex, and you're going to do that by substituting the x in. So you're going to substitute the x in for that part. For step 3, you're going to make a table of values starting with the vertex and then the next 2. So for step 3, you're going to make a table of values. And this one isn't going to have very many values in it. It's actually just going to have 3. And then for step 4, you're going to reflect your points across the axis of symmetry. So reflect the 2 points across the axis of symmetry. And all of that's going to make sense when we start actually putting this into practice. Now note, a common mistake that people will make is automatically putting x equals 0 or x equals 1 into your table. We cannot do that because your parabola could be anywhere on this graph. It might be way up here, it could be way down there, it could be way over here to the edge. We don't know where that parabola is. So we have to use the axis of symmetry first. That is step 1. So let's go ahead and just jump right in, and we're going to graph this equation right here. Step 1 is to find the axis of symmetry. Well, the axis of symmetry formula is x equals negative b over 2a. So we're going to take our values of these, and if you forgot what form this is in, this is y equals ax squared plus bx plus c. So the b is negative 6 and the a is an invisible 1. So let's substitute our values into this formula. So x is equal to the negative of negative 6 over 2 times 1, or positive 6 over 2, or 3. So right now, my axis of symmetry is at x equals 3. And you know what? I think I'm going to go ahead and put that in here just so you can see it. So x equals 3, and it's up and down. This guy is my axis of symmetry. Okay. But I don't know where the vertex is on that point or on that line. So I'm going to take this x equals 3 and I'm going to stick it back into my formula. And I'm actually going to go ahead and put that on in my table. So now I have y is equal to 3 squared minus 6 times 3 plus 4. Well, this is 9 minus 18, which is negative 9. Plus 4, which should be negative 5, but I will check that just in case. Yes, that's correct. So I've got negative 5 right here. So now I know my vertex is at 3, negative 5. So I'm going to go ahead and put that on here. How do you find your next 2 points that you want to graph? Just go up from your vertex, 4, 5. So I'm going to put a 4 in, and I'm going to put a 5 in. And I'm going to substitute those into my formula again. So here, I'm going to have y is equal to 4 squared minus 6 times 4 plus 4. And this one's going to be y is equal to 5 squared minus 6 times 5 plus 4. So this one, 4 squared is equal to 16, and 6 times 4 is 24. So what I'm doing is I'm taking 16 minus 24, getting me negative 8, and then negative 8 plus 4 is negative 4. And now let's figure out what my y value is for this one. So 5 squared is 25. That's 5 times 5. Minus 30, because that's 6 times 5. So 25 minus 30 is negative 5. Plus 4 is negative 1. So I now have these two other coordinates that I can put on my graph. If you need to pull them over here to the side, then you can, because I know sometimes it's hard for people to read it from the table. So I already graphed my 3, negative 5. Let's graph the 4, negative 4. So over 4, down 4. And then let's go over 5, down 1. Now, notice what we have going on here. Remember, this is the axis of symmetry, and when we have an axis of symmetry, that's cutting a parabola perfectly in half. I'll come up here and I'll show that to you. So here's my parabola, just some random one that I'm drawing. So if I didn't have that other half temporarily, and I only had the axis of symmetry, well, I could say, oh, well, I know what it's supposed to look like because it has to be reflected, so I know it has to look like that. And you can do this with anything. So what if this is your axis of symmetry and you have half of your parabola really close and going downwards? Well, you know that the other half would also have to be really close and going downwards to make it consistent. So that's exactly what we're going to do on our graph down here. We can see, oh, this dot is 1 over on the right side of the axis of symmetry, so now it needs to be 1 over on the left side. We're just reflecting it onto the other side. So this one will go here. Now we have enough points to connect, to make our parabola, and there we go. We have a graphed parabola. Step 1, find the axis of symmetry. Step 2, find the vertex. Step 3, make a table of values. Step 4, reflect them over the axis of symmetry. We're going to do it again in this next example. So in part B, we are graphing this. Step 1, find your axis of symmetry. So that is, I'll write the formula, x equals negative b over 2a. So my b is 4 here. So this is going to be negative 4 over 2 times the a is negative 1. There's an invisible negative 1 right there. So this is being negative 4 over negative 2, or 2. So I know that's going to be my x value. Now I'm going to take that 2 and substitute it into my value, or into my equation. So this is y is equal to negative 2 squared plus 4 times 2 minus 2. And you know what? I totally forgot. I'll try to keep it consistent. I'll go ahead and put a line through x equals 2 just so you can see it. Okay. This is my axis of symmetry, and I'm trying to figure out where on it is the vertex. I'm going to figure that out by taking 2 and substituting into my function. So now I have 2 squared, which is 4, but I'm taking the negative of that because there's a negative in front. So I'm at negative 4 plus 8 minus 2. Negative 4 plus 8 minus 2 is equal to positive 2. So now I know my vertex is right here. It's at 2, 2. I'm just going to go up from 2, 3, 4, to get my next two x values that I want to substitute into the function. And then we'll really be cooking. So I have y is equal to the negative of 3 squared plus 4 times 3 minus 2. 3 squared is 9. 3 times 3 is 9. The negative of that is negative 9. So now I have negative 9 plus 12 minus 2. So negative 9 plus 12 minus 2 is equal to 1. So my next coordinate is at 3, 1. finally, let's take this 4 and substitute it into our equation. So I have y is equal to the negative of 4 squared plus 4 times 4 minus 2. Well, 4 squared is 16. The negative of that is negative 16. Negative 16 plus 16 is 0, and 0 minus 2 is negative 2. So now I have 4, negative 2 for that next value. Let's plot these two coordinates. So I'm going over 3, up 1, and then over 4, down 2. Awesome. I only have half of a parabola right now, though. This is all I've got. How can I get that other side? Well, remember, this line of symmetry is a perfect reflection of the left and right. So if there's a dot 1 to the right of the line, then that means there needs to be a dot 1 to the left of the line. If there's a dot 2 to the right of the line here, then there needs to be a dot 2 to the left of the line there. Now we have enough coordinates and we can finish our parabola. We're going to do example C, and then that will be the last one for our notes today. And I'm actually going to change it just a little bit because I don't like exactly how this one's working out. So I am going to change this to y is equal to negative 2x squared minus 12x minus 1. So I'm basically just changing that negative 10 to a negative 12. Because this is going to go off our graph a little bit, which isn't the most convenient, but it'll be okay. So step 1, we're going to find our axis of symmetry. Our axis of symmetry is x equals negative b over 2a. Well, negative b is the negative of negative 12. So I've got negative of negative 12 over 2 times, and then we have negative 2. So now this is reducing to positive 12 over negative 4 or negative 3. So I'm putting my negative 3 in there. I'm going to go ahead, I'm going to put negative 3 for my axis of symmetry. There's my axis of symmetry going through x equals negative 3. But where on that axis of symmetry is my vertex? Well, let's plug negative 3 in and see if we can find something. So this is going to be y is equal to negative 2 times negative 3 squared. And then times, all right. Negative 3 squared is 9, and 9 times negative 2 is negative 18. So I've got negative 18 plus 36 minus 1, which is getting me 17. Not ideal, but that's okay. So we're going to go way up here, and I'll just pretend that this is at y equals 17, and we'll just say that's what that is. Okay, now I'm going to go 2 up. So I'm going to go to negative 2, and I'm going to go to negative 1. Let's put those values in. So I have y is equal to negative 2 times negative 2 squared minus 12 times negative 2 minus 1. All right, I have y is equal to negative 2 times negative 1 squared minus 12 times negative 1 minus 1. All right. So now we're just doing order of operations for both of these. So negative 2 squared is 4. 4 times negative 2 is negative 8. So I'm at negative 8 plus 24 minus 1, which is going to get me 15. So it's going over 1 and down a little bit. And I know it's off the graph, so I'm just kind of eyeballing it. I've had to shrink it because I've run out of space, but it's fine. And now let's substitute in our negative 1. So this is 1 times negative 2, or negative 2 plus 12, and then minus 1 Negative 2 plus 12 is positive 10, minus 1 is 9. So that would be like way down here. Alrighty, so now we're just going to reflect those across our axis, and our graph is looking kind of like that. It's not ideal, I know, because it's off the graph, but we kind of get the point. I am going to show you example D in class, so we are going to skip this for our notes, but I hope this is beginning to make sense as we kind of make our way into graphing quadratics. We find the axis of symmetry, we find the vertex, we make a table, and then reflect our points. That's basically it. So I hope you have a great night, and I'll see you soon.